Good morning, students. So we'll move on to the next topic of module number 3, that is the need for optimization. So in previous lecture, we were discussing about IP as network layer, like how we can impose the internet protocol as a network layer in our IoT communication. Fine. Now, in this session, we'll be discussing regarding why we need to go for this IP. Okay, without IP, what all different problem we may face. Okay, if you want to communicate with IoT network. Okay, so regarding this, we will have a glance about the complete limitations or constraints or different challenges, okay, what we are facing right now. Okay, and in next session we'll be discussing, like, okay, after imposing the IP, okay, then how we can overcome from all these kind of problems. Okay, regarding that we will be having the complete discussion. Okay, fine, we'll go for this topic, the need for optimize. Okay, the Internet of Things will largely be built on the Internet protocol suite. Challenges still exist on IP. Challenges still exist for IP in IoT solutions. So after posing the IP, like Internet protocol suite for our IoT network. Okay, other than that, okay, what all problem we were facing regarding if you are not including the IP as a network layer, okay, but also apart from that, okay, we have few other problems, okay, which also your internet protocol should address. Okay, we'll see that what are those problems exactly. In addition to coping with the integration of non-IP devices, you may need to deal with the limits at the device and network level that IoT often imposes. Okay, so in previous session we were having a discussion, like we are having two different procedure, like adaptation and adaptation. Okay, so we need to handle the non-IP supported devices. Okay, for that what we can do, we can go for some adaptation layers. Okay, so who is responsible for converting IP version to non-IP version, okay, and in reverse direction non-IP to IP version exactly, okay, for communication. Okay, second version is what we need to remove all those non-IP supported devices, and we need to deploy the devices which are only supported with IP factors exactly. Okay, so other than that, whether it is supportable for IP or non-supportable for IP, other than that, we are having some other limitations regarding the devices and regarding the network exactly. Okay, we'll see that what all the problems we may face from the device end. Okay, and what all the problems we may face by network level exactly. Therefore, optimization are needed at various layers of the IP stack to handle the restrictions that are present in the IoT network. Okay, both the nodes and the network itself can often be constrained in IoT solutions. So what we need to do, we need to go for implementing the optimization in different levels of our network. Okay, so that we can address the limitations what IoT devices are posing, or what IoT network is posing. Okay, we'll see that how it can be done. Okay, then what is this constraint node? Okay, constraint node in IoT, different classes of devices do exist depending on its functions in a network. A thing architecture may or may not affect similar character, or may or may not offer similar characters in an IoT environment. So here constraint node means what? Okay, see, we'll be having different kind of smart devices. We are considering them as nodes exactly. Feel that we are having total 100 different nodes. Okay, it is not compulsory like all 100 must have similar kind of a characteristics over here. Okay, few may be having different, okay, few may be having common. Okay, so here the limitations whatever we are having according to the device, we are calling it as constrained nodes. Okay, we are having some limitation, we have some problem, okay, which should be addressed, which should be solved. Okay, such type of devices we are calling it as constraint nodes exactly. Okay, so here the device characteristics and device function may be different. This may be the one of the constraint we may face when we are dealing with hundreds or thousands of nodes exactly. Another limit is that this network protocol stack on an IoT node may be required to communicate through an unreliable path. Okay, so this was first was constraint node. It is regarding a limitation of device exactly. Next, later these devices, whatever, whether it is a constraint or non-constraint devices, doesn't matter exactly. If they want to communicate using network only, they have to communicate. Is it? So now when they want to communicate, if they communicate using unreliable path, okay, then the receiving packets or the receiving information, whatever we are at application server level, okay, we may face different kind of problem over there. Fine, unreliable path, we may be having a noise, we may be having some errors, we may lose some packets over there. So such type of problem are still exist after deploying the IP. Okay, such type of problem still exists exactly, even in a full stack is, even if a full stack is available on the node. This causes problems such as limited or unpredictable throughput and low convergence with a topology changes occurs, or when a topology changes occur exactly. Okay, if you are deployed with fully stack, okay, if you are changing with the topology, because network to network, we may be having different topologies available over there, because in the in the user end we may be having one topology for connecting the application servers and all, we may be using some other topology exactly. If there is a change in the topology also, we may find such type of problem exactly. Power consumption is a key characteristics of constraint nodes. Okay, many IoT devices are battery powered with lifetime battery requirement varying from a few months to 10 plus years exactly. Then one more limitation we are facing in case of devices is the power consumption. Obviously we may not go for like online power supply completely for the devices. Okay, we have to go for battery based power supply. Okay, so offline based power supply we need to provide. Okay, so power consumption, okay, it is also very important problem we are facing, because few devices having a battery backup for few months or for a few weeks. Okay, and few devices are there who are having 10 plus years of battery backup. Okay, because their battery recharging system will be different. Okay, based on the heat available in the atmosphere, the battery may be charged. Okay, or any other kind of logic we may be using over there. Okay, so because of that the battery will last till 10 plus years exactly. Okay, so this is also few constraints what we can list when it come for devices. Okay, then and devices and network exactly. The IoT constraint nodes can be classified as follows. Okay, fine, we'll go for some classification. What are the different classification we can find? Devices that are very constrained in resources, observe those words, very important things they are. Devices that are very constrained in resources means the available resources, whether the bandwidth it may be, whether it may be power supply, or whether the data rate it may be, any kind of resources which is available and which is expected, most essential for the communication, may communicate infrequently to transmit a few bytes and may have limited security and management capabilities. Okay, so when we are having a limited amount of resources, then we need to go for infrequent transmission of information. Okay, and the security aspects and the management aspects, whatever we are having in the network, okay, that may not be implemented. So this is one variety of devices exactly, who is having very limited kind of resources, then they have to face such type of problem. This is one kind of constraint node. Then second, devices with enough power and capacities to implement a stripped down IP stack or non-IP. So second variety is what? We are having a complete resources with our devices. Okay, and we are having the IP stack, or we are having non-IP stack. Okay, in this case you may implement either an optimized IP stack and directly communicate with application server using some adoption model, or go for an IP or non-IP stack and communicate through gateway and proxies adaptation model. Okay, so this is the second variety. Okay, you are having full fledged resources available. Okay, you may be IP enabled or you may be IP non-enabled exactly. Okay, non-IP enabled it may be. Okay, then what we can do, the devices which are IP enabled, they may go for adaptation model. Okay, they may go for using some adaptation layer, okay, who is responsible for converting IP to non-IP, non-IP to IP exactly. Second version is what, if you are not with IP supported, then we can go for changing the complete structure. Okay, so those devices can be eliminated. That's why we are calling it as adaptation model. Okay, through gateway and proxies, okay, that we are calling it as adaptation. We need to go for some supplement. Okay, we need to go for, instead of using the layer, we need to go for some supplements who can provide the complete service, or who can allow us to reach the complete service exactly. See, we have observed when we are using some Wi-Fi, okay, like organizational Wi-Fi and all, okay, then we'll be having some restricted sites exactly, right? Some sites are available which should not be accessed by the students and all. Okay, such type of sites will be blocked by your administrator, network administrator. Okay, so what you do for downloading the movies and all, okay, you will be using some proxies, right? VPN, such type of proxies you will be using. Okay, so that is what the change what you are using. Okay, change what you are doing in your laptop or the mobile. Okay, so that you can get the access exactly. The restriction should be overcome. Okay, or limitation should be overcome exactly. For that, what all you are going to adopt, okay, that we are calling it as adaptation model. Then the third variety of a constrained nodes are devices that are similar to generic PC in terms of computing and power resources. How we are having a personal computer center, like power consumption will be, our power supply will be sufficient. Okay, continuous it will be. Then the computation power also continuous it will be, but have constrained network capacities, okay, such as bandwidth. Okay, but in case of network, we'll be having some issue. Okay, so those were the three different constrained device category. Okay, what we can opt. One is what, we don't have a limit, we are having a limited resources. Then what is the problem we are facing? Second is what, you are available with the resources, okay, but you need to go for some adoption and adaptation kind of variety over there. Then the third one is what, everything is fine, but you are facing some problem with network exactly. Then later, constrained networks we are having. We'll see that what do you mean by constrained network, what all problems we may face when it comes for the network end. Okay, constrained networks are often referred to as low power and lossy networks. LLN we call it as low power lossy network. Lossy in this context refer to network unreliability that is caused by disruption in the data flow or packet loss. Okay, so constrained network, it means what, low power consumption will be available, okay, in the network. Okay, and lossy network means the noise or the disturbance will be more using those channels. Okay, so because of that, we are having some obstacles during the data flow, and we have a problem of packet loss. Obviously, we are having some strategies which will allow us to avoid this kind of problem, but such type of problem do exist. Okay, for solution what we are trying to find, that is different exactly. Okay, but the problem what we are facing actually, okay, that should be addressed properly. Then constrained networks have unique characteristics and requirements. In in contrast with typical IP networks where highly stable and fast links are available, constrained networks are limited by low power, low bandwidth links. Okay, so these are the problems what you may face in case of a constrained network. Okay, so even though if you are available with highly stable and fast links, okay, but constrained network are limited by power and bandwidth exactly. Okay, whether you are using wired or whether you are using wireless doesn't matter exactly. So such type of problem we may face exactly. Then unstable link layer environments create other challenges in terms of latency and control plane reactivity. That is, the low bandwidth can lead to a network collapse. Okay, so this is also one of the main problem. Okay, because of low bandwidth, the whole network may get collapse exactly. Then control plane traffic must also be kept at a minimum. Okay, we need to keep it as minimum, otherwise it consumes the bandwidth that is needed by the data traffic. Okay, so these were the few discussion, okay, why we need to go for implementing the IP concepts or optimization of IP in different levels. Okay, so these are the very important reasons. Okay, so in next topic we'll discuss further, students. Thank you.